Hello there, here we are with yet another review. Today it's going to be Naive Set Theory by Paul Halmos. So let's say a few things about this book. First of all, pretty short book. It's 104 pages, as you can see, and this includes the index. So it's really 102 pages with a couple of pages of introduction. This book was published in 1960. The edition that I am using is a 1964 reprint with the same text. And it's a classic. I think it's a rather well-known book that I've read a lot of reviews about and heard a lot of as a recommendation for, people who want to delve a little bit deeper into set theory. Okay, so first let me tell you about the contents, and then I'll give you my impressions of the book overall. So the contents are presented here in this index that you can see, and I'm going to summarize them very briefly. The book is divided into 24 sections. Each of them is pretty brief. They occupy no more than 4 or 5 pages each. And out of those 25, you could divide them into subsections. For example, I'd say the first block is sections 1 to 10. So in sections 1 to 10, you get basically the introduction to the main elements of set theory. You get some axioms, axiom of extension, axiom of specification. You get you don't get a definition of sets, but you get enough to work with them. You get operations with sets like unions and intersections, complements and powers. Then you see ordered pairs, which you can make. They're a special type of set because generally sets don't order their elements. And finally, in the last sections of relations, functions, families, you get unusual but interesting types of sets or collections of sets that will be used in mathematics. Like functions, we tend to view them, just to give an example, as like these machines where you insert an input and you get an output. Set theory gives a different way of seeing a function as a set of ordered pairs. Anyway, so that first section just recaps basic set theory, what sets are, what are the rules for establishing sets, what operations can you do with sets. Then you have a brief section, which is chapters 11, 12, 13, which applies these tools of set construction to building the natural numbers. So you get the piano axioms in section number 12, and you get arithmetic, so how using only sets and using only the piano axioms, which include concepts like induction and the existence of the set, the empty set, which is 0, and the existence of induction and of the concept of a successor function. You can just build up the number system that we're used to from childhood, with addition and multiplication and exponentiation, which are translated into these set theoretic kind of ways of looking at things and into different combinations. Those operations are different iterations of successor functions. Okay, the next section, which goes, let's say, from chapter 14 to, I'd say, 22, it's a big section, or let's say 21. Yeah, let's say 21. So that section basically builds up towards the concept of ordinal numbers. It starts with defining order. So now you have sets with order. And where order gets explained, you get the axiom of choice and Zorn's lemma, which are ways of working with sets that are ordered. You get a version of recursion that was explained when we were talking about the natural numbers. But now you get one that can be used with objects that go beyond the natural numbers, transfinite recursion. And finally, you get the definition of ordinal numbers, which are basically an abstraction, a generalization from the normal numbers, as were defined through the piano axioms earlier in the chapter. So ordinal numbers are like well-ordered sets, which means every subset of an ordinal number has a least element. And also they are a transitive set, which means every element which is part of the set of an ordinal number is also a subset of that ordinal number, which is a really fancy way of saying that transfinite and ordinal numbers are like, well, not only the transfinite ones, all ordinal numbers are a bit like matryoshkas. They contain everything that went before. So like the number 2, which is an ordinal number, is the set containing 0 and 1. And number 10 is the set containing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the same thing will happen with the infinite or transfinite ordinal numbers. Finally, last section of the book, chapters 22 to 25, makes the same thing, the same development and build up towards cardinal numbers. And they're like the last thing in arithmetic. Cardinal numbers are a special type of ordinals, but they have the advantage of being defined in such a way that they are useful for comparing sets in a way in which ordinal numbers are not completely useful, for reasons that the book explains and that we're not going to mention in a short review. Also, you see, I didn't mention this, in the previous section on ordinal numbers, you see ordinal arithmetic, which is mostly like normal arithmetic, but has some weird properties like commutativity is not respected in ordinal addition and in ordinal multiplication. And here you also get cardinal arithmetic, which is how you can do addition, multiplication, and so on with cardinals, which again, it's pretty intuitive when you focus on the finite sets, when cardinal numbers are the size of a finite set. But when sets are infinite, cardinal arithmetic gives less than intuitive answers. Okay, so those are the contents of the book. And now let's go to the more personal part, which is my assessment. And I will introduce that by saying that my rating of this book is strictly personal. That is to say, it's based on how well this book worked for me. So if you are a different person from me, with a different background and different objectives, your assessment would be probably different. I only give it 3 stars out of 5, so it's a good book, but it's a less than optimal one. And let me explain why. So before reading this book, I've already finished, among other things, an undergraduate introductory course on set theory and logic. Well, I did it a few years ago. So when I took up this book, what I was looking for was something to consolidate what I had learned in that course and maybe to push it a little bit further. And it hasn't disappointed. It's a good book. I've learned a lot of stuff reading through it. I've really understood now what cardinals and ordinals are. And I've seen the piano axioms in practice. And I've been able to see the build-up from sets to natural numbers to ordinals to cardinals. But as I was saying, I took it up as a light read to just consolidate what I had read before. So the reason I chose it, first, it's, as I mentioned at the beginning of the review, it's a very popular book, and Halmos has a reputation for being a pedagogical author. It's small, as I said, it's less than 100 pages, so I thought it would be quite a breeze. I was thinking of maybe reading 2 chapters a week when I started reading this in April 2024. The book doesn't really have exercises as such. That is, every section has usually 1 or 2 exercises embedded in the text. Some have 0, some have as much as 5. But, they're not really formulated in a super formal way. So I thought it would be a light read and a way of consolidating knowledge. And I thought, this is a better time investment than just reading another textbook for a continuation of the textbook that I use for the course. So maybe a 300 or 400 page behemoth with lots of exercises, which would take me forever. Okay, so what's the problem with this book from my point of view? Well, it took me forever. This is what I like to call a vodka book. So like when you're drinking alcoholic drinks, when you're starting, when you're in your early 20s and drinking alcohol, it's very typical for you to drink combinations of strong spirits with some juice, and you start drinking that, and you're drinking it with your friends sitting in a chair, and you're thinking, okay, I'm happy, I'm feeling slightly jovial, but I'm okay. And then you stand up and you notice that the alcohol rushes into your head. You notice that you're blind drunk and you fall down to the floor. So I use the expression vodka book for books like this that are deceptively easygoing in the first chapters, and then suddenly, whack, they hit you around the head with a stick. This book is exactly like that. Like you start reading its first pages, it's really trivial stuff. And even the tone that is used for describing sets, like in the first page, sets have elements or members. An element of a set may be a wolf, a grape, or a pigeon, da, 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 da. You know, it's really colloquial, really informal type of language. Even though, you know, then it starts having rigor, it starts having, you know, mathematical notation, X is not an element of X, blah, blah, blah. But the book's difficulty starts to increase exponentially after you're into it. And in fact, you know, I was, you know, reading the book like 2 chapters per week approximately. When I reached chapter 9 on families, I was really flabbergasted. It was really confusing the way it was explained. I had to look all over the internet to really understand what Halmos was trying to say. This wasn't helped by the notation. And well, it was hard. And in the following chapters, I had to do some hard mental work. So this stopped being a light reading. I parked it for a few months. And then I think it was like in November of last year, I decided to take it up again. I read all through the previous chapters until the one I had stopped at, which was chapter 13, arithmetic. And then I got on, and I was in for a ride. If chapter 9 had been difficult, chapter 15, the axiom of choice, well, it still doesn't that bad, but chapter 16 was like another Everest. It was really a really tough chapter. I have in my Substack if you're interested, like 4 entries just trying to explain the proof of Zorn's lemma in understandable language. And yeah, that was difficult. Like that chapter 16 is just Zorn's lemma, the proof of Zorn's lemma, and it's hard going. And the next chapters, some were pretty difficult as well. So the learning curve becomes pretty steep. Other problems with the book, it's very terse. That's why it's only 100 and something pages, which means when it's explaining really difficult concepts, it doesn't really provide you enough of a scaffolding, enough of a set of examples or explanations. It's very terse, and that's not a problem in the first sections. It becomes a problem in the later sections. The exercises are also really random. Some of them are pretty easy. Some of them are incredibly hard. And like, you just don't know what you're going to get. The notation is weird. Some of the notation is the one we still use. This is a book from the 1960s. So some of the notation feels weird, and that doesn't help. That was one of the problems I had with the chapter on families. The notation was so weird, I had difficulty wrapping my mind around it. So that's why I decided to give it, as I said, 3 stars. I mean, the quality of the content is good. Halmos in the introduction says this is a book that contains all the set theory that a person, an undergraduate in mathematics, should know and then forget. That's the set theory he or she should really be familiarized with at least once in their lifetime. And as I said, the content is good and I learned a lot. But I really don't know who is the optimal audience for this book. This was definitely not a good follow-up book for a first course in set theory. In fact, I think it's rather more a late undergraduate, pre-graduate type of book for really getting to grips with what is usually called mathematical maturity, you know, the ability to fill in the gaps, to think deeply by yourself and to reach conclusions. I mean, I know reading math books is not like reading other books, but I've been stumped by these 4-page chapters time and time again. Like I've spent 2 or 3 days with the same chapter, going over it again and again and again, 4 hours per day, and, you know, getting really frustrated at how difficult it was to understand the book or how difficult some of the exercises were. So I would give it 5 stars for the quality of its content, but I'd give it like 1 or 2 stars pedagogically speaking. This is not a pedagogical book. Like, there is a kernel of a pedagogic book here, which would be a book approximately twice or 3 times as big, with no more extra content, just explaining, illustrating things with examples, and so on. and including exercises, and also scaffolded exercises with increasing levels of difficulty, but always in each unit having exercises that would be doable and exercises that are a little bit more challenging. Like there was no scaffolding for some of the exercises, like just with what you could read in the section or in the previous sections, sometimes you just couldn't come up with a proper solution. And I think that's it. So overall, I think this is a good book. I would recommend reading it, but I'm sure there are many, many better second set theory books to read. And if you go through it, you will learn a lot. But mind you, it's pretty harsh. It's not as naive as the title seems to imply. It's pretty dense stuff.